Okay, so a nucleus can have too many protons, or a nucleus could have too many neutrons, or a nucleus could just have too much energy. So in all three of those cases, the nucleus is, we say, excited if it has too much energy, and the way it gets rid of that energy is through radioactive decay. And there are three kinds of radioactive decay which you have to know for the exam. So the first kind of radioactive decay is by giving off an alpha particle. So an alpha particle is a helium nucleus, because the alpha particle is going to have two protons and then it's got two neutrons, so 2 plus 2 makes 4. So this thing is the same as a helium nucleus. So that's one way that a radioactive substance can become de-excited, is by giving off this particle. Now you're not going to be doing any of the chemistry of it. So you notice that next to the particle I have an example of how the radioactive substance changes as a result of it. Don't worry about that. Just know the definition of the alpha particle. It's the biggest of the three different kinds of radiation. So the second kind is the beta particle, and there are two kinds of beta particles. So if it's a beta minus particle, that is the same thing as the electron. So this one up here was the same thing as a helium nucleus. But then the beta minus is the same thing as the ordinary electron. Another kind of beta particle, though, is the beta plus, and it is a positron. So it's like an electron, but it has positive charge. Then the third mechanism is gamma radiation. So a gamma particle, so this is the symbol for a gamma ray, is its light. So do you remember when we talked about the electromagnetic spectrum? And we said that you had radio over here, and then next to it was the infrared, and then you had the visible, and then the ultraviolet, and then the X-rays, and then the gamma rays. So gamma radiation is light, very, very powerful light. So make sure and know that these are the different kinds of radiation. Okay, I also would like for you to know that a nucleus, as it decays, normally turns into another nucleus, which is also radioactive. And then that nucleus undergoes a decay and turns into another nucleus. And so this is called a decay series. I just want you to notice that you can start with one radioactive substance and it turns into a whole bunch of other radioactive substances. Now eventually it does decay into something that's stable. And in this particular case, it's turning into lead. But lead is not the most stable element. It would be iron. Okay, then we talked about the amount of time it took to decay. And this is where we get the idea of the half-life. So you need to know the word half-life, and you need to know what does it mean. So the half-life is going to be the time it would take for a particular radioactive substance for half of it to turn into something else. So that's the half-life. Now there's a formula that you could use to calculate how much time would it take for a substance to decay into another substance, a certain amount of it. You're not going to use it. So on the exam, this is the kind of question that I'm going to ask. So I'll tell you what the half-life is. I'll tell you how much are you starting with. And then the question is, how much are you going to end with after a certain period of time has elapsed? The best way to do it is by making up a chart. So you're going to make up a chart where up here is going to be the amount of time that's going to elapse. And you're going to start with 0. So the instant you click your stopwatch, that's going to be 0. And then underneath this, you're going to put the half-lives. So at the end of 1 half-life, 2 half-lives, 3 half-lives. And then over here, you start with whatever. So this is going to be the amount of material. And so in this particular case, you started with 1,000 of something. And then at the end of 1 half-life, divide it by 2. So take this number, divide by 2, and you put it here. And then at the end of the next half-life, divide by 2, and put that number down here. And you just keep going down until you reach your desired amount of time or the desired amount of material that the question asks for. So that kind of question could definitely be on the exam. But on this slide here, I actually calculated it using that formula. So don't worry about that. It's not going to be on the exam. And then I just want to show you that different nuclei have different half-lives. So these are the half-lives for different kinds of radioactive substances. Some of them are in billions of years, but others are only in seconds. Okay, let's take a break, and when we come back, we will talk about nuclear power.